In this video, we're going to look at the depth to which a cantilever beam has been plastically deformed given a load of 1.25 times the elastic moment. We'll work the problem in English units, so after opening ANSYS, I will come up to Units and click on US Engineering. I'll come down and drag a geometry. Double click on geometry to go build my cantilever beam. And while this is coming up, I'll go ahead and pause the video. So once Face Claim has come up, I close the dialog, I right click and select a new sketch plane, I select the XY plane, look at it face on. I come up to File, Face Claim Options, click on Units and change these units to Imperial. It automatically defaults to inches, and so I click OK. Now I go build my geometry. I'm going to build a rectangular geometry, so I click on my rectangle. I want to define it from the center, so I'll click on Define Center, come and click my center, move my mouse out, and I'm going to make this beam 3 inches wide by 1 inch in width or depth. So there's my beam. I'm going to go ahead and pull this into a long beam. I'll stretch it like 30 inches just to make sure I kind of get away from any end conditions. So that's my geometry. I can go ahead and close that. Come over to Static Structural. Drag and drop that on the geometry. Now I'm going to go to Engineering Data and set a yield strength for this problem. So I'm looking at structural steel. I'm going to click on it to get the properties, come down here, and Young's modulus is fine. I want my tensile yield strength though to be 30,000 psi. So I'm going to come over here to my units, change it to psi, and the default's 36,000. I'm going to change this to 30,000 psi and go ahead and click enter. Now I can close my engineering data. I'll come over into my model, and while that's coming up, I'll go ahead and pause the video. So mechanical is up, it's imported my geometry, here's my beam. I'm going to go ahead and mesh this beam. I'm going to pick on sizing. I'll do a uniform mesh, and I'm going to do a coarse grid, or a fine grid. Click update to get my mesh. That mesh looks like it'll be fine. I'm going to click on Static Structural, hit Support. So I'm going to do a fixed support on one end of this beam on this face. So I'll click there and click Apply. On the other end, I'm going to apply a load. I'll apply a moment. So I'll go ahead and click Moment, and this moment will be about the x-axis. So I'll click this face, click Apply, come to Vector, and hit Components, and then the x-axis. The elastic moment turned out to be 15,000, and I want to load this to 1.25 times 15,000, so I'm going to enter a moment of 18,750. So 18,750 would be my moment. Click enter. The units are pound inches, so that makes sense. In terms of a solution, I'll just look at the equivalent stress, and I'm able to go ahead and solve that. It should be a pretty quick solve, but so here's my solution. I will come up here to auto scale and turn off any deformation. I'll look at the beam straight on in the Z, and now what I need to do is come over here and scale my output. So I'll click on this 49 and I'll enter 30. If I double click on it, I can enter in 30,000. Actually, what happens here is it doesn't like you to change the maximum value, so come down to the next value, enter your, double click on it, enter your 30,000, click enter, and then you can come over here, click on that, and go -1, and so now your red's 30,000. And you can see here that up through this point I have stresses. The purple means that I have exceeded the yield strength. If I look at the other end of this beam, this is the clamped end, or the free end where I applied the moment. If I look at the other end, I can rotate this around, and you can see that this purple out here is where I've exceeded the yield strength. It's in here, and that comes close to matching the results that I had of 0.375 inches from the center out to the plastic deformation. So this concludes this video. I hope it's been helpful for this simple demonstration.